So far, we've looked at general solutions where we don't know that constant of integration, but now we're going to focus on finding a particular solution where we know what that constant of integration is. So the particular solution is the solution of the differential equation where C is known. The solution where C is known. And this is found using the initial condition or a point on the graph. The initial condition is a point on the solution used to help find C. Often it's given as an ordered pair. Let's take a look at an example and we'll go back and outline the steps. Find the particular solution. So this is telling us that we need to find the C after we solve the differential equation. Now this is telling us that we want the solution as y equals through the point 2, 4. This is our initial condition. It's telling us what point it has to go through for the differential equation here. So when I see y prime, first thing I'm going to do is I'm going to say dy dx equals 3x squared minus 1. I'm going to move my dx over so it says dy equals 3x squared minus 1 dx. This means derivative, so take antiderivatives. Then I get y equals, I do my power rule, get x cubed minus x plus a constant. This is a general solution. I want the particular solution, so I need to find the C. That's where my initial condition comes in. Take this x and this y, plug them in. Y is 4, x is 2. So 4 equals 2 cubed minus 2 plus c. Solve this equation, get c equals negative 2. Finally, I can write my answer with the c plugged back in. Y equals x cubed minus x minus 2. Particular solution because I know the C, general solution because I don't. So this one is the general solution. This one is the particular solution. All of it's the particular solution, all of it's the general solution. So let's review our steps. 1, find the antiderivative or the general solution or the integral. 2, plug in the initial condition or the given point. And 3, rewrite the solution using your known value of C. Let's look at another example. Solve this differential equation. Now notice here there's a double derivative, and solve means get no derivative. We want no derivative when it's solved, no derivative. What did I write here? Get no derivative, get no derivative. So I have a second derivative. I have to do 2 antiderivatives. So h double prime of t equals sine of t. Let's do 1 antiderivative. Here's how I'm going to write this one. Integral of sine of t with respect to t. If I want to, I could call this dh dt. That might help me to understand where this dt is coming from. So I do this and I get h prime of t equals negative cosine of t plus c. I don't know what the c is, so let's stop a moment and find it. H prime of this x value gives me this y value. So the y value is 1 when the x is 0. So 1 equals negative cosine of 0 plus c. Cosine of 0 is 1, so 1 minus 1, sorry, 1 equals negative 1, add that, and 2 equals c. So now h prime of t equals negative cosine of t plus 2. Okay, let's do one more antiderivative. Now I'm doing the antiderivative to get h of t, so the integral of negative cosine of t plus 2 with respect to t. H of t equals negative sine of t plus 2t plus c. In my given information, I know h of 0 is 6. So here's an x for this y. So 6, 0 here. So I have 6 equals the negative sine of 0 is 0 plus 2t plus c. Oops, plus 2 times 0. I had 2 places to plug in 0. That looks like c will be 6, and therefore h of t equals negative sine of t plus 2t plus 6. Let's look at another example. Here's one, instead of giving derivatives, talking about acceleration of a particle moving along the x-axis is given by this function. The velocity is here and the position is here. What's the position equation? Well, remember PVA in order of derivatives, position, velocity, acceleration. This is the first derivative of position. This is the second derivative of position. So basically they gave me that P double prime, or X double prime, they're calling it X instead of P. I'm going to call this P of t, so we think of it as position, is 6t minus 2. Therefore, P prime is the antiderivative of 6t minus 2 with respect to t. Therefore, P prime is 6t squared over 2 minus 2t plus c, or better written as 3t squared minus 2t plus c. Well, we need an initial condition. What is P prime? Velocity. And the velocity is 25 when time is 3. So 25 equals 3 times 3 squared minus 2 times 3 plus c. I solve for c, and I find c to be 4. Let's rewrite our P prime, or our velocity function, as 3t squared minus 2t plus 4. Well, I need position, not P prime. So P equals the antiderivative of 3t squared minus 2t plus 4 with respect to t, or it equals add 1 to the exponent, divide by the new exponent, gets rid of the 3. Same thing in this, and 4t plus c. But I know that the position is 10 when t is 1. So put 10 here, 1 here, solve for c, and we get c is 6. So my position function, or they want to call it x of t, is t cubed minus t squared plus 4t plus 6. One more that I've seen on an AP exam is multiple choice style. So either you can take the derivatives of each of these answers. We're looking for the second derivative of f given by this function, which could be the following function of f of x. So we're looking for two antiderivatives. We can do the derivative of each one of these twice and see which one gives us this, or we could do this antiderivative twice. Why don't you try it away, come back to the video, and see if you got the correct answer. Welcome back. The answer is B. How did I get it? Well, if we take two derivatives, we get 3x squared over 3 minus sine of x minus 1. One more derivative gives 2x minus cosine x, and done. That's what this looks like. But I'd have to test all of them, and that's kind of time consuming. So I'm going to also do it with antiderivatives. 2x minus cosine x dx, that gives x squared minus sine x plus c. One more antiderivative gives us x cubed over 3 plus cosine of x plus a constant times x plus another constant. I'll call this one d since I've already used c. So now I'm looking for something that resembles this pattern. I see the x cubed over 3, I see the positive cosine x, I see a constant times x and a constant. There we go.